Hi, this is question number 6 from the AQA Mechanics 3 June 2011 exam paper. In this question we have a projectile that is fired from a point O on a plane which is inclined at an angle of 20 degrees to the horizontal. The projectile is fired up the plane with velocity u meters per second at an angle of 30 degrees to the inclined plane. The projectile travels in a vertical plane containing a line of greater slope of the inclined plane. The projectile hits a target T on the inclined plane. For part A, we are given that OT, this distance here, is equal to 200 meters, and we need to determine the value of U, which is the initial speed. Now, in order to solve this problem, what we're going to do is we're going to resolve this horizontal to, and we're going to resolve this parallel to and perpendicular to the plane. So I'm going to resolve it in this direction, which is parallel to the plane, and this direction here, which is going to be perpendicular to the plane. Okay, so I'm going to call this direction X, and I'm going to call this direction Y. Okay, and I'm going to start by writing down all the information that I know. So I'm going to have the displacement in the X, okay, so in the X direction we've got this information here, and then also in the Y direction. Okay, now we know that the distance OT is 200 meters, so along the X direction my displacement is going to be 200 meters, so I can write that in here. Okay, I also know that the displacement in the Y, well, that's just going to be 0. It won't have displaced in the Y direction at T, so we can write that down as 0 meters. Okay, I also know the initial speed in the X direction. Well, that's going to be U times by cos 30, so that's going to be U cos 30 degrees. And I also know that displacement in the Y direction is going to be U sine 30 degrees. Okay, my final velocity I don't know at that point, but I know that my acceleration throughout motion, well, this is where it's different to our normal projectiles, because we're going to have a component of gravity here and a component of gravity here. So let's just think about where that component of gravity is going to come from. So if I've got my gravity, which is going to be obviously acting directly downwards, so if I draw in my gravity here, okay, so my gravity is going to be acting directly downwards, and a component of it is going to be going in the X direction, and a component of it is going to be going in the Y direction. So if I just bring that over here and show that there's going to be a component in the X direction, and also there's going to be a component of it in the Y direction. And the X direction and the Y direction are at right angles to each other, so I'm going to have a right angle in here. So that's G. And my angle here, well, if I bring this back over here, whoops, we can see that the angle with the X direction is going to be 70 degrees, because that's 90, that's 20, so this is going to be 70 degrees. So I can put in 70 degrees here. Okay, so now our x component is going to be g times cos 70, and our component for gravity, component in the y direction for acceleration is going to be g sine 70. Okay, and hopefully you can see where both of these have come from. So I'm now going to write that in here. So our acceleration, and because our acceleration is going to be going against our x direction, this is going to be minus g cos 70. Oops. And this is going to be against our y direction, so it's going to be minus g sine 70 degrees. Okay, we've now got the information that we need to answer part A. I'm just gonna, I'll leave this over here so that we can still refer to it. Okay, so part A. Okay, part A. What we're going to do is we're going to use the fact that S is equal to ut plus half at squared. So I'm going to first of all resolve this in the x direction. So I'm just going to resolve this in the x direction. So in the x direction, well, S is going to be 200, and U is going to be U cos 30, so UT is going to be UT cos 30. And we've got plus half at squared, and A is minus G cos 70, so half of that I'm going to write as take away and 9.8, so half of that is 4.9, so minus 4.9 t squared times by cos 70. Okay, so just to clarify that, I've got half AT squared, so half of the gravity is 4.9 and cos 70 times by t squared, and I've just written it in that order there. Okay, I'm now going to resolve this in the y direction. So my displacement in the y direction is going to be 0. And that's going to be equal to u times t, so this is going to be u sine 30 times by t, or ut sine 30, and then plus half at squared, which in this case is going to be take away 4.9 t squared sine 70. Okay, now what we want to do next is we want to eliminate our t's, so we're just left with our u's. So I'm going to rearrange this to get it in terms of t. Now if I start by factorizing, I know that 0 is going to be equal to, and we'll have t u sine 30 take away 4.9 t sine 70. Okay, now when the displacement in the y direction is 0, either time is equal to 0, so that's where it started before, or this part of our equation is going to be 0, and this is the part that I'm interested in. So I'm going to say that 4.9 t sine 70 is going to be equal to u sine 30. Okay, which means that t is going to be equal to u sine 30 over 4.9 sine 70. Okay, so I'm now going to I'm now going to substitute this into my x direction formula. So I'm going to replace the t's here with u sine 30 over 4.9 sine 70. So that's going to give me 200 is equal to, and u times cos 30 times by u times sine 30, so that's going to be u squared cos 30 sine 30 over 4.9 sine 70. Okay, and I want to take away, and we've got 4.9 t squared cos 70, and t is this here, so I'm going to have 4.9, and t squared is going to be u squared sine squared 30 over, and that's going to be 4.9 squared sine 70. So that's the 4.9 t squared bit, and I need to times that by cos 70. Okay, so I'm now going to factorize this. So u squared is a common term, so I can say that 200 is equal to u squared, and we'll have cos 30 sine 30 over 4.9 sine 70. And there's probably various ways of simplifying this, but I'm not interested in doing that at the moment, because in a second sine squared 30, in a second I'm gonna bang all this into my calculator, and 4.9 squared sine 70. Yeah, so I'm gonna put all this into my calculator and work out what u squared is. So u squared is going to be 200 divided by all of this here, and that works out to be u squared is equal to 2692.53. Okay, which means that u is going to be equal to 51.9 meters per second. Okay, a little bit messy, and I didn't want to bore you with simplifying this, etc. We just stick it into our calculator and that's the answer that we should have got. And that's part A. Now part B says find the greatest perpendicular distance of the projectile from the inclined plane. So the furthest perpendicular distance is going to be at this point here, and at that point here, Vy, the velocity in the y direction, or the rate of change of the distance in the y direction, is going to be 0. Yeah, so this here is going to be 0, and we can use that information to work out what the distance from here to here is. We start off by working out what time it's going to end up at this point, and then we can work out how far it is from the plane. Now I'm just going to tidy up my area a little bit to give me some room to work in. Okay, I'm going to start by working out the time that it reaches this point. So remember, at this particular point here, my velocity in the y direction is going to be 0. So I'm going to use the formula v is equal to u plus at. So we've got v is equal to u plus at. And remember, we're just looking at this in the y direction, so that's going to be 0, and uy is u sine 30, which we worked out to be 51.9 meters per second. And actually I'm going to use a more accurate version of this that I'd written down, which is u is equal to 51.894 meters per second. Yeah, I should have written this down earlier, and that rounded to 51.9. So I'm going to say that uy is going to be 51.894 sine 30 plus at, so that's going to be minus 9.8 sine 70 times by t, which is what we're trying to work out. Okay, so rearranging this, I can say that t is going to be equal to 51.894 sine 30 over 9.8 sine 70 and that equals 2.8176 seconds. Okay, now I know the time that it takes to reach that point, so I now need to know how far that is going to be vertically. So I'm going to use the formula S is equal to ut plus half at squared. Okay, and we're trying to work out the distance, so that's going to be that there, and uy is going to be 51.894 sine 30 times by t, which is 2.8176, so that's the ut split bit, and then we've got plus half at squared, so that's going to be take away 4.9 sine 70 and we're going to times that by t squared, so that's going to be 2.8716 squared, so 2.8176 squared. Okay, and if I put all of this into my calculator, it works out that this distance is 36.5622 meters, and to three significant figures, that's going to be 36.6 meters. Okay, and there you go. So that's going to be the greatest perpendicular distance of the projectile from the inclined plane. Okay, hopefully you found that clear and useful. Thanks very much for joining me. I look forward to seeing you again soon. Take care.